Hello and welcome. If you're watching this video, you're probably thinking of choosing computer science or have chosen computer science as one of your options. Either way, you're in the right place. The computer science course looks at coding, programming of computers, and what actually makes computers tick. So, what is computer science all about? Is it about playing games? Is it about programming and coding? Is it about inventions, robots, and artificial intelligence? Or is it about problem solving? Well, it's all these and much more. The aim of this course is to help students understand and apply the fundamental principles and concepts of computer science, which includes abstraction, decomposition, logic, algorithms, and data representation. Along the way, you're going to learn new skills that are not only useful in this course, but are useful in other subject areas and life in general. Some of these skills you're going to learn include creativity, problem solving, critical and logical thinking, communication skills, perseverance, and resourcefulness. For instance, if you have a problem, how do you go about solving the problem? Do you break down the problem into manageable bits and try to solve these little problems? And by so doing, you end up solving the main problem when you have finished solving the smaller problems. These are some of the things that we are going to look at in this course. Also, your curiosity to find out how things work would be heightened because there are a lot of hows and whys that need answers. So, what is the course structure like? The course content is split into two subcategories, Paper 1 and Paper 2. Paper 1 is about computer systems, and Paper 2 is about computational thinking, algorithm, and programming. There is also a practical programming task that you would have to do. This is the project work. The aim of the project work is to help consolidate some of the concepts that you will learn in paper 1 and paper 2. So, what does paper 1 contain? The topics covered in paper 1 include systems architecture, where we drive down and look at the CPU and its components. What actually happens between the components when they are exchanging data and in what manner they do exchange the data. We'll look at memory and storage devices such as hard disk drives and SSDs. We're also going to look at computer networks like the LANs and the WANs. We'll look at connections and protocols like FTPs, SMTPs, HTTPS. We're going to look at how when you compose an email and you click send, how it moves through the network and gets to the destination device. We're also going to look at network security and look at concepts like SQL injection, denial of service attack, hacking, viruses, trojans, worms, and would also look at ways to mitigate against such threats. We also look at system software, how operating systems interface with the hardware so that they are able to perform the functions that they do perform. We would also look at the ethical, legal, cultural, and environmental impacts of digital technology on us and the environment. Now, what does paper 2 cover? The topics covered in paper 2 include algorithms. We'll be looking at searching algorithms like binary search, linear search. We will also look at sorting algorithms like merge sort, bubble sort, and quick sort. We also look at programming fundamentals. We'll look at how to create robust programs, what goes into creating these programs. We would also look at Boolean logic, where we look at the AND gate, the NOT gate, and the OR gate. We would also look at some programming languages like Python, C Sharp, Java, and JavaScript. And we would look at some of the softwares like Visual Studio that will help us when we are programming in these languages. So, like any other course, at the end of the course, there is an assessment. The assessment is an external one administered by OCR, which is the examination board that is used by the school. You would be assessed in both paper 1 and paper 2. Each paper is an hour and a half minutes long. For paper 1, you would have multiple choice questions, short answer questions, and extended answer questions. In paper 2, your ability to write and refine algorithms would also be tested. Your project work would also be marked in the school and submitted to the examination board at its OCR for moderation. After which your grades will be released, or you get your qualification, which is based on the 9 to 1 scale, where 9 is the highest and 1 is the least. So what happens then? After your GCSE, what happens then? You can decide to do apprenticeships, or you can decide to either do any of the vocational IT courses in level 1 and level 2, or you can decide to do computer science for your A level, after which you can do a computer science related course in the university. Now, when you have done all of this, some of the career pathways for this course includes software engineer. You can decide to go into CGI animation. You can be a system analyst. You can be a data scientist. You can be an IT consultant. You can be a database administrator. Or you can decide to work for Microsoft. You can decide to work for Apple, Google, Intel, or Amazon. Or you can even work for the European Space Agency. Or better still, you can start your own company. Who knows? Probably you might be the next tech giant. No one knows. So, as you can see, there are a whole lot of options. There are a whole lot of options open to you just by choosing the computer science option. I hope this has been useful enough, and I'm looking forward to probably seeing you in my class if you should choose this option. If you need further information or would like to have a chat about the contents of this video, feel free to contact the computer science department and we'll be glad to help. Remember, we are all different, all equal, and all flourishing. This is life in all its fullness. Thank you.